You've seen how to add, subtract, multiply, and divide integers. The properties of integers affected the sums, differences, products, and quotients. In this video, we look at the properties of integers and how they affect exponents of numbers and expressions. Let's start with an example. Each of the side lengths of this cube has a length of 5. Write the volume of this cube as an integer to an integer power. The volume of a cube is summarized by this formula. V equals s cubed. The exponent is a positive integer. So to find the volume of a cube of side length 5, write 5 cubed, as shown here, and 5 cubed is equal to 125. Let's look at another example. Each of the side lengths of the smaller cube has a length of 2. Write the volume of this cube as an integer to an integer power. Write the total number of smaller cubes as an integer to an integer power. We take the formula for the volume of a cube and replace s with the side length. We are told that the length of each side of the smaller cubes is 2. There are 3 small cubes on each side, so the side length of the large cube is 6. So the volume of the larger cube is 6 cubed, or 216. Now let's figure out how many small cubes there are. There are 3 cubes along here, 3 along here, and 3 along here. So there are 3 times 3 times 3, or 3 cubed, or 27 small cubes. Let's look at another example. The gravitational effect on an object near the Earth is an inverse square of its distance from the Earth's center. Write an algebraic expression that shows the inverse square. Evaluate the expression for r equals 100. The diagram shows the distance r from Earth's center to the rocket is the variable. The inverse square of this term is written this way: 1 over r squared. The inverse means taking the variable r and writing its reciprocal, 1 over r. The term square means writing r squared in the denominator of the term. We can now evaluate this expression for r equals 100. Replace r with 100 to get 1 over 100 squared, which is the same as 1 over 10,000, which can also be written as 10 to the negative 4th power. Another way of writing the inverse square term is this way: r to the negative 2 power. Let's look at a final example. Write this expression with all variables having positive integer exponents. Notice that there are terms with negative integer exponents, here and here. Let's start by moving this w term to the numerator and making its exponent positive, as shown here. Next, we take the y term and move it to the denominator, making its exponent positive. We now have all terms with positive integer exponents.